This lesson is an introduction to vectors in 2 dimensions. What is a vector? A vector is a mathematical quantity having both magnitude and direction. Example 1. Given points A, B, we want to find vectors AB. Vector AB means we start from point A and go to point B, whereas if I say I want to find vector BA, it means we start from point B and go back to point A. Let's do a diagram first. We put the points A and B on the Cartesian plane, and we draw a line segment from A to B because we're finding the vectors AB. And we put the arrows on point B, indicates this is the head of the vector. However, whenever we represent a vector, we always represent the position vector. That means we have to find position vector AB, which means we have to move the tail of the vector at point A to the origin 0, 0. At the same time, we're going to look for the new location of the head for point B. Let's take a look. In order for point A to move to the origin, I have to do A units to the right and 2 units up. Then we will need to do the same thing for point B. A units to the right and 2 units up. So we're going to have a 0, 0 for point A now. Let's call it O. And point B will become 3 and 4. That becomes P. By connecting O to P, it becomes the position vector of AB. So we say vector AB equals the vector OP, and vector OP is the position vector of vector AB. Now let's find vector AB algebraically. So we know vector OP equals the vector AB, and vector AB can be found by using the point B and add the opposite of point A. So which we say vector AB equals to OB minus OA, which means negative 5, 2 plus 8, 2, which will become 3, 4. So vector OP equals vector AB equals to 3, 4. Therefore, we say vector OP and vector AB are equal vectors, which means they have the same direction and magnitude. Now let's take a look in terms of the ways that we can express a vector. Method 1, we can express a vector using algebraic vectors, which indicates the location of the head, given that the tail is always at the origin, which is the position vector. Method 2 is called geometric vector, which indicates the magnitude and the direction of a vector, but without telling us the location of the head. Under each representation of the vector, we have 2 different notations that we can use. The first one is called order pair notation. So let's look at the diagram on the right. Vector OP can be written as 3, 4, which indicates the location of the head as an order pair. The second notation is called unit vector notation. We are using the unit vector of x-axis, which is this one. We call the unit vector I, which is defined as 1, 0, and unit vector j, which is defined as 0, 1. And unit vector is being denoted by a upside down triangle. So vector OP can be written as 1i, 2i, 3i, plus 1j, 2j, 3j, 4j. So we write down vector OP equals to 3 of the unit vector I plus 4 unit vector j. For the second representation, geometric vector, we always need to find the magnitude and the direction first. The magnitude of a vector can be denoted by the 2 straight lines around the vectors. And by looking at the diagram, we know the length of vector OP can be found by using the Pythagorean theorem. So we know square root of 3 squared plus 4 squared will equals to the length of the vector OP, and which is square root of 9 plus 16, which is square root of 25, which is going to be 5. Next, we have to find the angle of the vector, and the angle we are finding is always referring to the vertical line, which is the north and south line. In order to find this angle alpha, we can see there's a right triangle. That means we can use primary trig ratios to help us to find angle alpha. So we can write tangent alpha equals to opposite of adjacent, which is 3/4. That means alpha can be tangent inverse of 3/4. Alpha is approximately 37 degrees. Like the algebraic vectors, geometric vectors also have two different notations to represent it. The first one is called true bearing. True bearing is using an angle that is measured clockwise from the north line. And it is always represented by 3 digits. So we will write vector OP equals to 5, which is the magnitude, and use a square bracket represent the angle 037 degrees. The second one is called quadrant bearing. It is also known as compass bearing. That means we always measure from the north or south line towards the east or west. So we write vector OP equals to 5, once again using a square bracket. So north 37 degrees towards the east. Please note that whenever the angle is 45 degrees, because it's halfway between north and east, then we will just write down northeast instead of writing north 45 degrees east. Next, we're going to learn how to find the unit vector of a vector. So we know unit vector is being represented by the symbol an upside down triangle, which is called a cap, or sometimes you can hear people say V hat. Unit vector U is a vector of length 1 in the direction of the non-zero vector U. Using the previous example, we know vector OP is having a magnitude of 5, and I want to find the unit vector of OP. This implies that we have to cut the vector OP into 5 equal pieces, such that the first piece will become our unit vector OP because it has length of 1. Now let's enlarge the graph and look at the location of the head of the unit vector. As we can see from the graph, vector OP originally have an x value of 3 and y value of 4, but since we have to cut into 5 equal pieces for both x and y values, that means the first piece, the x value will be 3/5, and the y value will be 4/5. So we say unit vector OP is 3/5, 4/5. Now, let's find unit vector OP algebraically. So we say unit vector OP equals to vector OP divided by the magnitude of OP, which is 3/4 divided by 5, which is 3/5, 4/5. Now, we have mentioned what equal vector means, which means they have the same direction and same magnitude. So what does it mean by opposite vectors? Opposite vectors means they have the same magnitude but the opposite direction. That means if you switch the head and tail, it becomes the opposite vectors. Now, let's look at an example here. There is a square A, B, C, D, and with the diagonals intersecting at point E. Part A, we want to find 2 pairs of equivalent vectors, means we want to find equal vectors. So let's look at the diagram. If I want to find an equal vector to vector AB, that means they have the same direction, same magnitude, which is vector DC, because if you put the point D to point A is, then C will overlap with point B. That means they have the same direction and same magnitude. Another pair we can use is vector BE, which is going to be the same as vector ED, because if you put point E to where point B is, then point D will overlap with point E. That means they have same direction, same magnitude. Part B, we want to find 2 pairs of opposite vectors. That means they have the same magnitude but opposite direction. So I can say vector AB and vector CD will be opposite because they have the same length, but the head and the tail, it got switched. Or I can say vector BE and vector EB, they are opposite vector as well. Part C, we want to find 2 pairs of vectors whose magnitude are equal, but the direction are perpendicular to each other. As we know, this is a square. That means the diagonals will intersect at a 90 degrees angle. Therefore, I can say vector AE and vector EB, they are perpendicular. Or I can say vector AB and vector BC, they are perpendicular and having the same magnitude. Now, let's do a summary for the vector in two-dimensional plane. So vector U can always be written as a position vector, and AB is the location of the head. And we always can use Pythagorean theorem to find the magnitude of the vector U. And unit vector can be found by using the vector U divided by the magnitude of the U, which is denoted by a cap or a V hat on top of the U. And there are two ways to represent the vector U. The first one is called algebraic vectors, which indicates the location of the head. It can be written as order pair notation or the unit vector notation. The second way is called the geometric vectors, which indicates the magnitude and the direction of the vectors. There are two ways to represent the direction. First one is called true bearing. True bearing is a measurement where the angle is written in 3 digits and is measured in a clockwise direction from the north line. And the second one is called quadrant bearing, also known as a compass bearing. It is a measurement between 0 degrees to 90 degrees, east or west of the north-south line, which is also the y-axis. So if you look at the picture on the right, we said vector V is having the angle south 35 degrees east, or we can say true bearing of 145 degrees from the north line.